I'm excited here today to tell you a bit about crowdsourcing and virtual reality. So before I begin, I guess just out of curiosity, how many of you have experienced virtual reality yourself? Okay, great. So I don't need to go in more details about how virtual reality is a powerful technology that can simulate realistic experiences. This talk is about combining the power of virtual reality with that of crowdsourcing. We believe we have run the world's first 3 crowdsourced virtual reality experiments. In this talk, I'm going to tell you why it's important, how we did it, and what it means going forward. So to understand why it's important to combine virtual reality with crowdsourcing, we draw this table of comparison across 4 areas of dimensions: manipulation realism, measurement granularity, participant diversity, and reproducibility. So virtual reality is very strong in delivering highly realistic experiments, making it very suitable for strong experiment manipulation. In addition, a lot of the VR devices have built-in sensors in it, so making it very high in granularity of measuring things, such as head orientation. But at the same time, current virtual reality research, especially academia, has the problem of low participant diversity, mostly using undergrad participants. So that's one of its biggest disadvantages or limitations so far. And also, finally, it's very hard to replicate, to run, and let alone replicate a VR study, making it very low in reproducibility. So these 2 weaknesses, participant diversity and reproducibility, are actually the very 2 strengths of crowdsourcing, since we have a lot of experts here in the room. So I don't need to go into details of that. So if we combine the power of crowdsourcing and virtual reality, wouldn't that be amazing? So we can basically get the best of both worlds. So that's why the motivation of crowdsourced VR is important. So the next question is how? How do we combine the VR and crowdsourcing in a way that's feasible to create an effective paradigm for actually running these experiments on the web? And more concretely, we ask 4 research questions. So first, are there any workers out there with their own VR headset who are eligible and willing to participate in these experiments? And second, once we find them, how do we direct them to a flow in VR and maybe survey back in the desktop? And then third, what types of experiment manipulations we will be able to deliver in VR? And finally, what are the limitations and challenges of the current state of limitation and maybe also a worker population? So to give a sneak peek of our contributions, we first validated a VR-ready panel on Mechanical Turk, Amazon Mechanical Turk, which is one of the most popular crowdsourcing platforms. And then we designed and implemented an effective user flow to conduct studies. I will show you examples in a bit to run these studies. And then third, we replicated 3 previous studies, some in VR, some without VR, but designed to show the capacity of crowdsourced VR experiments. And then last but not least, we got a little deeper understanding of the state of the art, of the limitations and challenges of crowdsourced VR. And we also open source our data and code for easy replication and adaptation to run your own crowdsourced experiments, which we're quite excited to see what will come out of it. So I'll use this slide as the outline for the rest of my talk, and I will go into each of the points in more detail. Before I proceed, are there any questions so far? Okay, cool. So first, validating a VR-ready panel. So to see if there are any crowd workers out there with their own VR headsets and are willing to participate in our experiments, we designed a sort of validating or screening task and posted through Amazon Mechanical Turk. So we invited crowd workers who own their own VR devices from a list of approved devices to participate in a survey. To prove that they have access to a VR device instead of a picture of one, we asked them to take a picture of their VR device, but also in the background have a piece of paper with their last 4 digits of Mechanical Turk ID written on it. So we accepted the qualifying ones and rejected the ones that appear to be scamming us. As you can probably see, it's not too difficult to tell that apart. You can probably train a very simple image-based model to do it automatically, but we did it manually. So next, we received 242 valid submissions in total. In the same survey, we also asked the worker about their demographics, and we reported below. I'll give you a second to read the graph, but there are mainly 2 takeaways from the slide. So if first we observe that this population does not differ significantly from the overall Turkic population tracked by literature and surveys over the years. So there's no evidence that people who own VR devices are significantly richer or anything like that. And second, the VR-ready panel is more diverse than the usual college student population, which is a promising direction in addressing the one of the key limitations of current VR research, which is participant diversity, but it's still not enough. There are still key limitations in this sample as well. Next, now that we have a potential population of crowd workers that already have these devices, we have validated that, can we design a good user flow to direct them to complete VR tasks? So there are several design goals for this flow. First, it should be usable at least. Second, it needs to be a web-based, so we can allow for remote participation. The motivation is, as a grad student, I don't want to bring participants to the lab and run them one by one. I prefer to launch the experiments and go to home and do something else and come back and see the data. And third, ideally, the technical barrier for implementing such an experiment should be lower than the current the standard, which is familiarity with game engines such as Unity, which is quite time-consuming, at least, if not challenging. So to achieve these design goals, we chose the following technical platform: JavaScript-based UI framework for VR on the client side, and Node.js on the other side. If you have no idea what I'm talking about, that's fine. It's easy to do. A college kid could just pick it up and do it very quickly. And again, the code and everything is available on GitHub. If you're interested, you can chat more. I'll skip through this to the user flow. So here's the flow. A worker accepts a task on a web-based Mechanical Turk platform, and then it contains a URL for the VR web app that we just developed. So the worker goes to the URL in their own VR devices and completes the VR part of the experiment. Then they will unlock another desktop-based survey, after which they will receive a second verification code, which will direct them back to the Mechanical Turk interface, and after which we verify the code, and then we'll pay them. The task is then complete. Now we have the participant, we have the flow. Let's run some experiments. So when we were choosing the experiments to run, we want to be very strategic about which first experiments to run. We want to maximize the demonstration power. So to do that, we use a framework of models of VR illusion to guide our selection of experiments. So the framework models of VR illusion basically states that the VR's capacity to deliver illusion can be broken down into 3 main types: the place illusion, embodiment illusion, and plausibility illusion. Place illusion just means you feel like you're transformed to a different environment. Embodiment illusion means you feel you are the avatar that's representing yourself. And then the plausibility illusion is what you feel is taking place in the real world. You think that's actually happening. So based on this framework of illusion, we chose 3 studies to replicate, but because of time limitation, I'm going to show you the videos of 3, but I'm only going to go into the details of the results for the first one. So I'm about to show you the VR portion of the first study, which is the study on the restorative effects of virtual nature environment. So in the study, we first show the participant a thriller video to increase their psychological stress, and then we play clips of nature such as beach or tree to see if we decrease their negative affect. And increase the positive affect. Each video is 2 minutes long, which I trimmed here, and also I omitted the audio. So the dot here in the center shows the center of the participant gaze location, which we track. Okay. Now moving on to the second study, the Protoss Effect. This study is one of the most iconic and most cited paper in VR. It basically says that the setup of your virtualized self, your avatar, is going to affect your behavior. So if you're assigned to a taller avatar, you're supposed to behave more dominantly. So that's great because my advisor is a former basketball player, so he's like super tall, and I have to listen to him all the time. So we were curious if we can replicate this study in VR, and to do that, we built our own version. So this is the standard negotiation game, and how people split money is an indicator of how dominant they are. And you can see they're either playing with a mini avatar or a really tall avatar. And then finally, the Milgram study. In 1969, Milgram and students conducted a study using pedestrians of New York as participants on the street. So they hired actors as stimulus crowd and stand in the middle of the street to look up to the sky. And then they measured the percentage of pedestrians who looked up and stopped. So here's the graph showing the percentage of people who looked up and stopped on the y-axis, and the size of the stimulus crowd on the x-axis. As you can see, the more as the size of the stimulus crowd increased, the higher percentage of passerbys will stop and looked up. This shows the conformity behavior in human beings, in that other people's behavior, especially that of crowds, can draw you into it. Like people would just line up on the street without asking what people are lining up for. So this happens over and over again. Also sharing articles that you haven't read because our friends are sharing it. Yeah, so we replicate that in VR as well. So that's particularly awesome because you don't have to hire the actors. Obviously, it's super expensive. And also, again, as a grad student, a lot of my study is driven by the motivation of how to simplify my life. So I don't have to go through the recording and manually count how many people stopped or looked up. I can just analyze the data and plot the distribution of their gaze. So here's the study. So there are 10 avatars, half male and half female, who acted as a stimulus crowd. Some of them are looking to the back of the participant, some of them looking to the same direction. The participant was instructed to look for an object that will appear randomly at a random interval. And then we we give them a 3-minute time window. During this 3 minutes, we log their head orientation for 5 times per second as our dependent variable. So to simplify the analysis, we only focus on one axis of the head orientation, which is yawning, basically looking to the left or the right. So here is some notation to illustrate the results of this study. You're looking from top down at the participant. The default field of the view of the VR headset is 100 degrees, which is roughly this zone to the front. And then based on this, we divide the space into 4 zones, 1 to the front, 2 to the left, and 3 to the back, and then 4 to the right. So later we will plot the maps of gaze distribution based on these 4 zones. So we had a between subject design. I'll quickly plot these out. Basically, it's the same as more participants looking to the back. And as you can see, in the first condition, people spend most time looking to the front. And as the number of avatars increase who look to the back, they follow their gaze, and then looking in the back, spend more time in the 4th zone. So that's our 3 replicated studies. And just very quickly, because I'm low on time, we did some analysis on how our methods improve the state of art of running experiments, and we're able to do it faster and cheaper, and also make it easier to run these experiments. So I can talk more offline about the limitations and challenges, but just for now, I just want to close with some skipping through some of the discussions, and just with this vision of combining crowdsourced VR and the possibility of running scalable VR experiments. Thank you very much. It's a pleasure to be here.
So there's a lot of different VR devices out there right now. Were there any devices or platforms in particular that your team liked more than others in terms of the data that you gave you?
Yeah. So we ran this study last year, and at the time, Gear VR was the most popular one because it was cheaper and more affordable. So we tested solely on that, and our participants were restricted to have that. But now the devices are getting better, so Oculus Go is probably one of the most affordable that's out there, and it's with pretty good performance. But hopefully we'll see more diverse platforms.
What are the kind of areas of like this is what we science and this can be applied, like all this seems kind of psychology driven, like a crowd of people is influencing the way you look at the world, like what are those disciplines, for your organization?
Yeah, so in one of the slides I skipped, it's one of the social psychology in early 2000s imagining doing this. So obviously there are a lot of uses in human subject disciplines with that, be that psychology, sociology, maybe neuroscience, and see how people's attention is allocated. But there are more computational implications, such as you can maybe label videos, especially 360 videos, and see if you can predict how people will feel in different environments. That's I know some people are working on that. And also, if you're with a more business-focused angle, you can begin to think about how to allocate ads in 360 and augmented reality and test that in a much easier way than you would have been in the traditional setting.
These studies, have they gone through the purity process?
Yes.
So the methods themselves that you're using to conduct research are being peer-reviewed and accepted into the scientific literature?
Yeah.
That's awesome.
No, this is Thanks. This is just a plug, I guess. This is published at the 2018, this past WWW, the web conference. It's one of the premier web technology conferences, and acceptance rate is like 40% or something, like 1.4, yes. So it's pretty, yeah, rigorous.
Well, thank you. Let's see.